Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, I will talk about unleashing the power of adaptability with Azure App Configuration. In the dynamic world of software development, adaptability is key. Azure App Configuration is a service that enables you to centralize your application settings, making your applications robust, adaptable, and scalable. It's like having a magic wand that allows you to manage your application settings in real time, ensuring optimal performance and user satisfaction. Imagine you are a software developer at a thriving e-commerce company. Your application is loved by thousands of customers worldwide. However, to change some of the most important configuration values or to expose a new feature to a subset of users, your application needs to be redeployed. That is causing downtimes and frustration, which is why you're looking for a better solution. Enter Azure App Configuration. With its dynamic configuration and feature management capabilities, you can easily modify app settings in real time without redeploying your app. Azure App Configuration is your silent hero, making your application resilient and adaptable while saving time and resources. So why wait? Dive into the world of Azure App Configuration and experience the magic of adaptability at your fingertips. In this video, I will explain the benefits of using Azure App Configuration and describe how Azure App Configuration stores information and how you can organize and retrieve it. Azure App Configuration provides a strong service for managing application settings and feature flags from a central location. Cloud applications often have many distributed parts that can face problems with configuration settings. If these settings are spread across different parts, it can cause hard-to-find errors when deploying the application. With app configuration, enterprises can bring all their application settings together, making sure they can access and manage these essential configurations efficiently and securely. I hear you thinking, Michael, isn't that what we use Azure Key Vault for? No, it is not. Key Vault is your secret store, keeping everything secure you don't want to get exposed. App configuration should be used side by side with Key Vault, and it will take care of application settings that aren't necessarily secrets to be kept. I will compare the two services and how they are accessed on the next whiteboard to make this more clear. Now, as I just said, Azure Key Vault is your secret store. A secret store obviously keeps secrets. So basically just anything that you would like to not be exposed in log files or on command lines. And also things that you don't want your applications to have direct access to, like hard-coded or being in files and repository. You can store keys. These keys are usually used for disk encryption, for example, or you could also store RSA keys in there if you work with this. And the third category that we store in an Azure Key Vault are certificates. Certificates that you would like to manage and made available for your applications from this. And then next to it, and as we said, like preferably running side to side, would be the config store, the configuration store using app configuration. Following this principle of separation of concerns, we should use both, and not only that, and probably on top also more of those. So don't think of using just one key vault for all applications or just one config store. Think about if it makes sense to break them down even and provide multiple instances depending on what kind of exposure you can tolerate or what level of security you want. In configuration store, obviously, whatever you store in there is also protect. So, but don't think of this, what is stored in there is not kept a secret, but think of it as like more a light secret. Things that are more focused on, let's say, performance, how fast they can be retrieved, different bandwidth or different organizational features, like what I'm just going to talk about right now. So in Configuration Store, we store basic key value combinations. That could be anything your application used to configure settings or provide a certain user experience. It could be anything specific to a component or an application or user sessions. You can apply labels to these key value pairs, which is something that we unfortunately don't have in Key Vault. And these kind of labels would allow you to target individual deployment environments like development, production. So you could have an entry representing a different value with the same key, but with a different label applied. And the Configuration Store offers this integrated feature flags management, where you can configure features and provide a state for them being either on, and then they will be exposed to the user in code, or if they're off, then it will just go down a specific path, not exposing these new features already. So these are the main difference between these two. So let's box them up. And then I'm going to explain what is different in the way our applications or your code is accessing these different services. Both of these services provide endpoints where you can access them using a specific URL with a URI and access keys that you provide to this. You can provide either RBAC configuration permissions, or you can use access keys to access these endpoints and authenticate. So I will zoom out this a bit. So now that you have seen this all a bit bigger, I will zoom out a bit and make this a bit smaller. Hopefully you still can read this, and then I will continue. Obviously, the most common resource that we're going to use in such a scenario would be some kind of application, a web app hosted on an Azure App Service, for example. The app service itself will then, of course, run code on top. That could be the code like in a specific runtime environment, or we can even run this as part of a container image. For each app service instance, we also have a way of provide configuration, application settings, general settings, path mappings, and all of these different kinds specific for this instance. So environment variables that you would like to pass through to what is running on top of that. So it's pretty much what the config store can do for you too, but this is only specific to one instance. Now what is going on if you have not just one instance, but you have multiple? Think about dozens, not just maybe 2 or 3 like what I'm showing right now, but if you have multiple of those, every time that you would like to change any configurations, you would need to do this individually for all of these instances. And that is, of course, a little bit more effort and a little bit more challenge to keep this all in sync. So instead, it would be best practice to let the code, in fact, reach out to the endpoint through the config store and read information from there, and then provide just the means in code to make this possible, read the values at runtime, and decide then or run based on this values. And you can do this from all different codes. And if the code is the same running on all these different instances, no matter where they're hosted in whatever region or what part of the world, they get a central location where they can read the configuration values. With Key Vault, I can do exactly the same thing. So we can instruct code to reach out to the Key Vault either API or use a specific Key Vault as an instance, as an endpoint to reach out as well. So let's decide here on a color that I'm going to use for this. There are different libraries, different methods that we'll use for this, but the basic idea, the pattern is the same thing. Now it's a little bit of spaghetti here on the whiteboard, but yeah, hopefully you'll get the idea. Just for completion, I want to mention one more thing. We can also create, specifically for web apps or app servers in general, we can create, as part of the configuration of these instances, can create references directly to a key vault. So I could have a value where I say, here's that value, its name is connection string, and yeah, I want you to get the value as a reference from my key vault. So when this variable is read by your code running on that app service, it will reach out to the key vault and then read that value directly from the key vault. So you don't have to provide it with the instance. And obviously that requires also that your app service instance has the permissions to read these secrets from the secret store. We don't have this option for the config store. We can only directly access this in code. But for the key vault, we have these both options. Again, the downside here with these references is if you want to change these kind of references, then you need to go and do this individually for each instance. What we can do is you could actually create a reference inside of the app configuration service for a specific key to be also a reference for a specific secret stored in Azure Key Vault. So your code can reach out to config store, applying labels and all the different features in here, but actually getting the value from the key vault itself. That leaves you with a more secure scenario, but that is also a very specific use case. So you have to really think about if that is something you would like to implement. The benefit here is clearly that config store offers these label feature, but also feature flags that would allow you to add an extra layer of, let's say, flexibility to what the key vault cannot currently provide. So if that is something you would like to follow on, then that's a good way of configuring these kind of references. So hopefully that makes sense and you understood now how you can access these different services and how it makes sense to have them both in place and not just one of them. Application configuration provides these benefits: flexible key representations and mappings. Keys are used to identify and access key values, which store and provide values for your configurations. Keys are case-sensitive strings that can contain any Unicode characters. Tagging with labels. Labels help you to organize your configuration settings into meaningful groups. For example, you might use different labels for development, staging, and production environments. By applying suitable labels to configurations, you can quickly change between different sets of settings based on the environment. There's a dedicated UI for feature flag management. Azure App Configuration has a user-friendly interface that is made for managing feature flags, or feature toggles as they're also known. This UI lets you turn features on and off without having to redeploy your application. Enhance security through managed identities. With managed identities, we allow your application to authenticate with Azure App Configuration in a secure way without having to handle explicit credentials like connection strings or secrets. And data encryption at rest or in transit. App Configuration keeps your configuration data safe. It offers native integration with popular frameworks, where it seamlessly integrates with frameworks like .NET and Java Spring. These libraries and SDKs let you conveniently access your configuration settings from your application code. Keys are names that identify key values and are used to save and access their values. A common way to arrange keys into a hierarchical namespace is to use a character delimiter. On the upper part of this slide, you can see an example of key names organized into a hierarchy based on component services. This makes keys more readable since the delimiters in a hierarchical key name act as a space in a sentence. They create natural breaks between words. Moreover, a key name hierarchy shows logical groups of configuration data. And sure, Keys can be flat too, but bear in mind that they also are case sensitive. App configuration allows key values to have a label attribute. And labels are for distinguishing key values that share a key. These labels enable you to create variations of the same key. A typical use of labels is to indicate different environments for the same key, as shown in the examples on the slide. The value for the DB endpoint here varies based on the label used. It's time to see app configuration in action now. Let's go to a demo. In this video, I will show you how to use app configuration to dynamically change configuration values. And I want to do this based on a website that I'm hosting on an app service. This is the website eShop on Web. And now let's say there are a few things that we would like to change. So for example, there's this notion here where when I select a Visual Studio brand and then just search for it, it has a message coming back, a text that is presented that says there are no results that match your search. And that looks a little bit strange with all capitals and so on. So I would like to provide a nicer image on this. Now, what I will do here is I will go to my app config Contoso demo instance. This is app configuration, which provides an endpoint where we can reach this in code. It's running in the free pricing tier. And I have only one setting here currently configured, which is a no result message. So let me show you what that is. And this text that we just saw is actually coming from this configuration. It's not coming out of a file or it's not hard-coded in the text. To prove this, I will go ahead and change this file, not necessarily in the more professional way, but let's say we just want to show that there's some change. So I will go ahead and apply this. And the idea would be now to go back to my website, which doesn't have to be redeployed or doesn't have to be changed in any other way. It's just running as it was before. And if I refresh and then search again, I can tell that, or I can see that the message has actually changed to what I have just dynamically changed in there. So how does that work? How did I do this? So in code, if I change to Visual Studio Code, you can here see that element of that website where we don't have like plain text written in here, but in this case, we are getting a specific setting for this no result message. And where is this coming from? So in the website configuration, we have a feature, or we have a variable that is used to enable app configuration. And what that allows me to do is, because I will show you this in a moment, or basically, let me just go back for a real bit. So in here, in the web app itself, if I check the configuration of the web app instance, if I show you the configuration here, there are two things that are important for this scenario. One, I have this setting here that says, yeah, please use app config. If this is set to true, then we go into that specific code path that I just showed you. And so that it knows what instance it needs to contact, we have the endpoint configured in here. So this is the endpoint that is coming, or that is provided by my app config instance that I showed you. So because I have this is referring to this setting here, right? So this use app config setting, and it's adding app configuration, and also feature management. So I will show you this in a moment as well. And what that means is when this is set to true, it will read this text here. And this is exactly the key that I showed you, no results message with this hierarchical key, eShop web settings, no results message. And then we'll update this every couple of seconds. Right now it's kept for 30 seconds. So actually that is for 10 for the configuration. The feature flag is updated every 30. Oh, it says 30 here, but it's actually 10 for both. Okay, I was thrown off by the parameter here. And we have, of course, embedded also the app configuration management library that makes this available. And now what that allows me to do is to instruct my application to say, hey, read these configuration values from that central instance. I don't have it somewhere in the code, not in a repository, so I can change this in a central place from outside without redeploying anything. Also, what we have done here is to enable a certain feature flag. So I will just show you this for now. It's coming up, this explanation of what that all entails and how that works. But you can also tell that we have here in the beginning, there's a specific section where we will only show a specific picture when the sales weekend feature is enabled. This is what that means. So basically this tag here, feature, says this belongs to a specific feature configuration. There's some other parts in the code that make this possible, but that is the important thing to know right now. So when I go back in here and switch to my app config, we have an integrated feature manager tool in here, and you can tell that there is a feature called Sales Weekend that's currently not enabled. So what that means is if I go back to my website, so if it would be enabled, then we would see a message saying here that the weekend sales is on. Some t-shirts are discounted. So let's try if that works. So the idea of a feature manager or a feature flag is that someone who doesn't need to be a developer has a UI like this and can basically just go and add and enable this feature. Nothing else is to be done. I will refresh the website right now, and it will take 10 seconds, obviously. And here is our message: all t-shirts on sales weekend. And even if someone would say, oh my God, I didn't know what that does, they can switch it off again. And in the same fashion, without redeploying or anything else, they refresh this again. After 10 seconds, the message goes away. So that gives anyone a control to work with either dynamic changes of configuration values or feature flags without redeploying using app configuration management. In this unit, I talked about the benefits of Azure App Configuration. I also described how Azure App Configuration stores information and how it is organized. In this next unit, I will talk about the security features of Azure App Configuration. We will look at how you can securely access your app configuration information. Azure App Configuration uses a 256-bit AES encryption key from Microsoft to secure sensitive information at rest. Each app configuration instance has its own encryption key that the service uses to encrypt sensitive information. Sensitive information includes the values in key value pairs. When the customer managed key feature is turned on, App Configuration uses a managed identity for the app configuration instance to authenticate with Microsoft Entra ID. The managed identity then accesses Azure Key Vault and wraps the encryption key for the app configuration instance. The wrapped encryption key is then stored, and the unwrapped encryption key is cached in app configuration for 1 hour only. Every hour, App Configuration updates the unwrapped version of the encryption key for the app configuration instance, and this process maintains availability under normal operating conditions. Private endpoints for Azure App Configuration let you access data over a private link from clients on a virtual network, a VNet, in Azure. The private endpoint uses an IP address in the VNet's address space for your app configuration store. The network traffic between the clients on the VNet and the app configuration store goes over the VNet using a private link on the Microsoft Backbone network, avoiding any exposure to the public internet. Applications on the VNet can use the same connection strings and authorization methods to connect to the configuration store over the private endpoint as they would normally do too. You can use private endpoints with any protocol that the app configuration store supports. The benefits of using private endpoints for your app configuration store are: You can protect your application configuration details by setting up the internal firewall to block all connections to app configuration on the public endpoint. You can increase the security for the VNet by making sure data doesn't leave it. And you can connect the app configuration store securely from on-premises networks that use virtual private networks or ExpressRoute with private peering to connect to the same VNet. Managed identities make it easy to manage secrets for your cloud applications. With a managed identity, your code can use the service principal of the Azure service it runs on. You don't need to secure a separate credential in Azure Key Vault or a local connection string. Azure App Configuration and its .NET and .NET Framework and Java Spring client libraries have built-in support for managed identities. To use these libraries is highly recommended since they remove the need for an access token with secrets. Your code can access the app configuration store with just the service endpoint. And you can put this URL in your code directly without revealing any secret. Your configuration store can be granted two types of identities. A system-assigned identity is tied to your configuration store as a resource. It's deleted when your configuration store is deleted too. A configuration store can only have a single system-assigned identity. A user-assigned identity is a standalone Azure resource that can be assigned to your configuration store. And a configuration store can have multiple of these user-assigned identities. In the next demo, I will show you how to use a system-assigned managed identity to grant your code access to app configuration. In this video, I will talk about how to use a system-assigned managed identity with app configuration. And I showed you this example before. We have this website, eShop on web, and I showed you how I can use, for example, the features or the text that is provided in a specific search function here that will dynamically change the not necessarily, you can say the behavior of that website or how it determines. So I have enabled this feature. Now I will see that message here again. Now, but how did I do this? Because if we look at the code, we can tell here in this line that it is using the connection or the connect string of the library for configuration management, and it's using here the default Azure credentials. Default Azure credentials is a class that is part of the Azure Identity namespace in the Azure SDK for .NET, and it's available in others as well. And it offers the default token credential authentication flow for applications that will be deployed to Azure. Not only to Azure, but it makes most sense to when it's also hosted in Azure, because in this scenario here, we have a managed identity enabled for the app service where this code is running on. And with when you use default Azure credential, it automatically tries different credential types in a specific order to authenticate your application. And the managed identity is, I think, the third or the fourth one of those. So if it finds that this application has, or not that application, but the resource where this application code is running on has a managed identity, it will use this. And that is exactly what happens. You will find nowhere in this code an identity that is given, or a password or a secret that needs to be get from Key Vault or anything. It will just use this to get access by using the managed identity. But how is this set up? So the first thing is that for our app service, which is hosting the website, I need to make sure that there's an identity, a system assigned identity created and enabled. By enabling this, it will automatically create an identity for this resource only in Entra ID. And it has done this using this object ID in here. And now this app service, this web app, has its own identity. And what we did then in that app configuration instance, where we have the configuration for the value, this message here, for example, that is shown, or the feature flag, we have made sure that there's an assignment for a role of the configuration. Let me just filter this a bit here. Configuration. It's looking for the name, not the role. So we have a role assignment for app configuration data reader. That is a specific role that allows an identity to read information from app configuration, not change it, not delete anything. And this here is the identity of my web app that is running. That's all I need to do. So with this present in code, the setup with the role assignment on the resource that my code needs to access, which actually is, we use the identity for the web app, and then we have that flow where we contact the management or the metadata service built into app service to get an access token on behalf of that identity of the web app through the code, and then read the values outside of or inside my application. So that is how this is set up, as easily as you can do this. No need to provide any credentials in your code, and you can get your application to access any Azure resource that has support for this sort of roles management. In this next unit, we will learn how to unlock the magic of controlled features with Azure App Configuration's feature flag management. Meet Pax, the head of marketing at Contoso Webshop. She's got a sparkle in her eye and a mission: boost sales during the upcoming weekend. Contoso's webshop is abuzz with anticipation. The big weekend sale is around the corner, but the exact date is still a mystery. Pax wants to be ready. She doesn't want to bother the IT team every time she wants to activate the sale. Pax discovers the power of feature flags in their Azure App Configuration. She grins. It's like having a secret switch that controls the sale offers. No code deployments needed. Pax creates a weekend sale flag. When it's off, the sale offers remain hidden. And as the weekend approaches, she flips the switch. Voila! The webshop lights up with discounts. Contoso's weekend sale is a hit. Customers flock to grab deals on cosmic gadgets and Starship accessories. Pax team celebrates. No late night deployments, no frantic calls to IT, just smooth sailing. In this video, I will talk about the feature flag management and how to implement it. Let me clarify a few terms related to feature management. A feature flag is a variable that can be either on or off. The feature flag has a code block that goes with it. Whether the code block runs or not depends on the state of the feature flag. An application package that manages all the feature flags in an application is a feature manager. The feature manager also does other things, such as storing feature flags and changing their states. A rule that decides the state of a feature flag is a filter. Some possible filters are user groups, device or browser types, geographic locations, and a time window. For feature management to work well, it needs at least two parts that work together: an application that uses feature flags, and a different place that keeps the feature flags in their current state. This place is Azure App Configuration. A feature flag declaration consists of two parts: a name and one or more filters that check if a feature state is on, that is, when its value is true. A filter specifies a condition for when a feature should be turned on. If a feature flag has multiple filters, the filter list is gone through in order until one of the filters enables the feature. Then the feature flag is on, and the rest of the filter results are ignored. If none of the filters enable the feature flag is off. The feature manager can use app settings JSON as a file to store the configuration flag definition. In this unit, we talked about how to implement feature flag management. Now you have now unlocked the capabilities of Azure App Configuration Service for centrally managing and securing your application configuration settings. By leveraging this service, you can streamline configuration management and ensure consistency across your applications. With Azure App Configuration, empower your team to efficiently manage configuration settings and accelerate your application development process. Thanks for watching. Keep on learning.